So we finally reached stoichiometry. This is a quantitative way to show the amounts of substances involved in a chemical reaction. Essentially, we will be using the coefficients in balanced chemical equations to determine the amounts of other substances. So let's look at this balanced chemical equation here. 4Fe plus 3O2 yields 2Fe2O3. What this really represents in a balanced chemical equation is that there's 4 moles of iron reacting with 3 moles of oxygen and producing 2 moles of Fe2O3. If you can keep that in mind and understand that these coefficients represent the number of moles of each one of these substances, you'll find that stoichiometry will be quite easy. So let's go through and check out what this really looks like. You'll see that we have 4 moles of iron, 3 moles of oxygen, and 2 moles of Fe2O3. That's a ratio, which means if I tripled the amount of iron in moles, if I had 12 moles of iron, I would have 9 moles of oxygen that react with that 12 moles of iron, and I would produce 6 moles of Fe2O3. Notice the ratio stays the same, and if one goes up, they all go up according to the stoichiometric ratio. So let's go through a couple of examples. Of course, you're going to need to know dimensional analysis once again. If you have trouble with dimensional analysis still, please go see my previous podcast dealing with that topic. How many moles of Fe2O3 could be produced from 7 moles of Fe? We're going to assume we have as much oxygen as we need to produce the Fe2O3. So let's look. We start off with 7 moles of iron. We put it over 1. And we look at the ratio of units. Now we're trying to figure out how many moles of Fe2O3. So let's look at our ratio here. We have 2 moles of Fe2O3 in our equation. And we have 4 moles of Fe in our equation. So the ratio is 2 to 4, or 1/2. Well, 7 times 2 divided by 4 is equal to 3.5 moles of Fe2O3. Notice the moles of Fe has canceled out, and we're left with only moles of Fe2O3. As long as you can remember that, it doesn't get any harder. Let's look at another example. How many moles of O2 are needed to react completely with 8 moles of Fe? We're going to do the same thing, except now we're going to see how many moles of oxygen are needed to react. So we start off with 8 moles of iron, and we want to know how many moles of oxygen are going to react. Well, look at the equation and look at the ratios. 8 moles of iron. The ratio of oxygen to iron is 3 moles for every 4 moles. 8 times 3 divided by 4 is equal to 6. So if we have 8 moles of iron, we will need 6 moles of oxygen to react completely until that iron is gone. If I wanted to produce 0.680 moles of Fe2O3, how many moles of oxygen would I need? We want to produce 0.680 moles of Fe2O3. So what I'm going to do is I'm going to start off with that number. And since we want to know how many moles of oxygen we need, I'm going to multiply by that ratio. There are 3 moles of oxygen for every 2 moles of Fe2O3. Notice in this case, the moles of Fe2O3 will cancel out. And if we multiply 0.680 times 3 divided by 2, you'll see we need 1.02 moles of oxygen. So it comes down to understanding what chemical reactions mean in terms of moles and being able to do dimensional analysis and convert one of the substances into the other.